Hello friends, welcome to my channel. Let's have a look at a newly appeared problem, problem 2531. Make number of distinct characters equal. In this video, we're going to explain a solution based on the practice of dictionary data structure, or just see some basic usage of dictionary methods. First, I'll read through the problem statement, and then we do the analysis, and finally we share the code. First, the problem statement. We are given two zero-indexed strings called word1 and word2. So next paragraph defines what it means by a move. A move consists of choosing two indices I and j, such that the two indices are inbound according to the corresponding word length, and then we do the swapping. So we are required to return true if it's possible to get the number of distinct characters in word 1 and word 2 to be equal with exactly one move. Otherwise, return false. So here are three examples. So let's look at example 3 first. So in example 3, so both word 1 and word 2 consist of 5 unique characters, and these sets as unique characters they do not have intersections, so we can do swap any with any indices. So in this case, the return is true. So both words have 5 different unique characters. So in example 1, so it's impossible. Actually, as a set, the A, C, and B are different, right? And then no matter what we do this, no matter how we do the swap, so word 1 contains 2 unique characters, and word 2 contains just 1. So we return false. So example 2 is a case in which that we can do the swap to make the unique characters equal. So in word 1, so there are 3 unique characters A, B, C, and in word 2 there are 2 unique characters, right, A and B. But here A appears twice, so if we swap A with a C, right, so we have made the 2 words have the same number of unique characters. So this returns true. So before we do the analysis, let's also look at the constraints. Actually, in this problem, the second constraint plays an important role. So the length of word 1 and word 2 are bounded in between 1, which basically meaning the 2 words are not empty, bounded above by 10 to the power 5. So this 10 to the power 5 basically defines the problem size. So the second constraint is that word 1 and word 2 consist of only lowercase English letters. So these actually are very important, because in order to count the unique characters and their corresponding frequencies, we need to use dictionary in this problem. So because of this assumption or hypothesis, so the dictionary length will be at most 26, because there are 26 lowercase English letters. So this is about it's or on the second constraint. So with that said, we are ready to look at the problem analysis. So here in this video, we're going to give a treatment based on the dictionary abstract data type and its basic methods. So here, as we mentioned, or based on the second constraint, so there are 26 lowercase English letters, and therefore the number of unique characters in each word is bounded above by this constant 26. Therefore, we could try the swaps. In other words, we can consider all possibilities. So these possibilities are bounded by 26 times 26, right? We could use the subclass counter of the dictionary class in Python to do the job. So with that said, basically we are ready to do the coding. So in order to do the coding, first let me get the unique characters and their frequencies, right? So here we need to pay attention to those characters especially it appears once, right? So if you do the switch, so there will be a decrement in the number of unique characters in word 1 or word 2. So here, let's say collections counter. So here I'm going to use word 1, and then let's copy this part. So this will be the counter for word 2. So the key will be the unique characters, and the value will be the frequencies. So with that said, so we are ready to do the job, to do the swap. So do the swap. So basically we tried all the possibilities. So for A in count 1 and for B in count 2. So notice that we know that dictionary is mutable, so we need to pay attention to the state. As such, I'm going to do this ref1, ref2 to be count 1, and I can use a copy of it, count 2 copy, right? And then let's do the swap. First, let's swap AB in word 1 and 2. So ref A, so it's decremented by 1, and ref 1 and B is incremented by 1. So similarly, ref 2 A is increased by 1, and ref 2 B is decremented by 1. So these are the swap and the corresponding state change of the two dictionaries. And then we need to check if ref 1A equals 0 now. So we need to delete this key, right? Similarly for ref 2B. So we're going to del ref 2B. And once we finish the swap and clear the case with 0 occurrences, so we're ready to do the comparison. Length ref 1. So we're going to just count the keys, right? So if it equals ref 2 keys. So in other words, we check if they have the same number of unique characters. If so, we are ready, we are done, we are going to return true. So if after the for loop, so the nothing has returned, so we are going to return false. So up to now, let's first do a check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So here, before we end this video, let me make a comment. So here we used the copy method for the dictionaries. So actually, if you do not use this one, so after we do the swap and then compare the key, then we can swap back to recover the original state of the dictionaries. So that's also a way, but this saves us some thought or thinking. So with that said, I guess that's about it for this video. Thank you. So you are welcome to comment and check out other videos in my channel.